Okay, hi, year 11. Just check if my recording is working. Yes, it is. Okay. All right, so we are going to look at the cubic function today. So I'm expecting you to download this PDF and to copy down everything that I do. All right, so here we go. So cubic graph is of this form here. Okay, ax cubed plus bx squared plus cx plus d. Now a, b, c, and d are constants, and a cannot be zero. Okay, a can't be zero because then you wouldn't have a cubic, you'd have a quadratic instead. Now the constant term is d. Here it is, the constant term is d, and that's the term without any pronumeral. The coefficient of x cubed is a, so there it is. Can I circle that? There it is, a. That's called the coefficient of x cubed. All right, so let me just rub that out. Don't need that anymore. Don't need that anymore. Okay, now what happens when a is bigger than 0? So what happens when this number is positive? Well, you get a cubic looking like this. It goes from concave down to concave up. So if I'm going to trace over that, let's say I've got a marker. Let's try this one. Yep. So it's concave down up to around about there. And then let's change colors. And it's concave up in this section here. Now, importantly, there's a point called the point of inflection. And the point of inflection is around about here. So where it changes from concave down to concave up, that is called a point of inflection. So that's how it's said there, point of inflection. Okay. Now, what about on the other curve? Well, on the other curve, let me see if I can stick to using my pen. Now, here, this is a bit harder, easy with the highlighter. This is concave. What went too far there? Concave. Let me rub that out. I'll just stick to the highlighter, I think. Here we go. All right. So concave. Whoops. Concave up till about there, and then concave down to this section. Okay. Now, how do you know when that happens? Well, it's when the coefficient of A is negative. So when A is negative, you go from concave up to concave down. And when A is positive, you go from concave down to concave up. Now, just be aware though that you have a point of inflection. So where it changes concavity, so just here, this point here. So yep, that little point there. So it changes from concave up to concave down and vice versa. That is called a point of inflection. Now, just to abbreviate that, sometimes we write down P-O-I, POI, point of inflection, okay, which is written down there. Okay. Now, what about turning points? Obviously, with the cubic, sometimes you do have turning points. Sometimes you don't. But in this particular case, you do. Here are the turning points there and there. And here is a turning point here and here. Now, these turning points, they have special names. This is called a local maximum. Okay? Local maximum. And this point here is called a local minimum. Local minimum. Okay, now why is it called a local maximum, local minimum? It means because locally, that means in that little neighborhood of points there, that is the minimum y value. And why is this called a local maximum? It means because locally, in this little neighborhood of points around here, that is the highest y value. Okay, that's why it's called a local maximum, local minimum. Okay, some cubics don't have local maximums and minimums. We'll look at those a bit later, but a lot of them do. Okay, so let's look at the next bit we're going to do. Okay, and here are some examples of real cubics I put into the computer and graphed. Now, have a look at this one. It goes from concave up to concave down, doesn't it? So just have a look at the cursor, concave down to concave up. Where would be the inflection? The point of inflection, I'm guessing, is around about here somewhere. Right? Later on, we learn how to find those points exactly. Here, this goes from concave up to concave down, and the point of inflection where it changes concavity is around about there somewhere. Now, how do I know this is going from concave down to concave up? Have a look. My coefficient of x cubed is positive, okay? A is greater than 0. Over here, have a look. Coefficient of x cubed is negative. A is less than 0, okay? So concave down to concave up, you have a positive coefficient of x cubed, and concave up to concave down, you have a negative coefficient of x cubed, okay? Notice also the constant term 3, positive 3. Look, that is the y-intercept, isn't it? And over here, well, I should have done this a bit better, but 4.1, if you look, this is a little bit above 4. 4.1 is the y-intercept of that cubic. Okay, now on these documents, there are live links you can click on. Here they are. And you can play around with these cubics for different values of A, B, C, and D. Let's have a look what this looks like. Allow. Remember this action, so I don't have to keep doing that again. Okay, here's your cubic. This will load in your browser. You should be able to use it. Now, let's look what happens to A. So see, I'm changing the value of A. Okay, now I don't know how to get rid of that red circle. I'll figure that out next time. Now you can see the value of A here is changing the equation. Now, what happens when A becomes negative? Concave up to concave down. What happens when A becomes positive? Concave down to concave up. Now, why is the cubic disappearing when I change the values? Because it can't show the whole graph there. It's got too big of the values. Sometimes you can zoom in on the... No, you can't. Wait, you can actually... No, I can't zoom that. That's all right. So let's bring it back into the picture. What does B do? Well, that's what B does. Just moves things around a bit. It stays. Notice it stays in that basic concave down to concave up shape. Okay. And same thing with C. What C does, it keeps it in that basic concave down to concave up shape. And then D just moves it up and down. You can see that. So have a play with that. Make sure you can see both turning points. So when you do the changing of the values for A, which is what I'm doing now here, make sure you can see both turning points. Okay, turning point there, turning point there. That way you can see how the graph is changing. All right, let's go back to your document. So you've had to play with that. Now, what else is interesting? The domain. Okay, here we go, domain and range. Well, the good thing is domain and range is infinity in both directions, from minus infinity to infinity. All right, there's all x and y values are allowed. That's fantastic, makes it nice and easy. Let's move on. Now, what about these factored cubics? These are quite interesting. So now we're going to look at a cubic of this form. This is a cubic. Why is it a cubic? Is because if I multiplied x, x, and x together, that'd be x cubed, wouldn't it? It'd be a cubic. So this is actually a cubic. And k is the coefficient of the x cubed term, isn't it? So if I went x times x times x times k, the coefficient would be k, because your cubic term would be kx cubed. You'd also have quadratic terms in there and x terms and constant term as well. Okay, what's so special about this? Well, at x equals a, you have an x-intercept. At x equals b, you have an x-intercept. At x equals c, you have an x-intercept. Now, how come? Well, it's because if you put x equals a into the first bracket there, you're going to get a minus a, which is 0. And 0 times whatever is in the other brackets is 0. Same for x equals b. Put x equals b in there. B minus b is 0. The other brackets won't be 0, but the middle one will be, and that makes the whole expression 0. Okay, so anytime you see a cubic in factored form, x minus a, x minus b, x minus c, it means that you've got x-intercepts at x equals a, x equals b, x equals c. Okay, here are some examples. So look at this one. This is 2 bracket x minus 1, x minus 2, x minus 3. Right, and notice that the x-intercepts are at x equals 1, x equals 2, and x equals 3, because these x values will make this expression 0. Okay, put x equals 1 in there, what do you get? 1 minus 1 is 0. 1 minus 2 is minus 1, 1 minus 3 is minus 2, but because you've got a 0 in the first bracket, the whole expression is 0. Okay, so now let's look at the next one over here. Look at this. 2 bracket minus 2 bracket x minus 1, x minus 3, x plus 2. Now at x equals 1, there you go. There's the x-intercept. Okay, and at x equals 3, okay, x equals 3, there's the x-intercept, and look, if I put x equals 3 into that bracket, I get 0. Now what about this one, x plus 2? Well, the x-intercept is negative 2, and you might be saying, how come it's negative when there's a positive? Is because if I put into this bracket here, the last one, if I put x equals negative 2, what do I get? I get 0, and 0 times the whole bracket is 0, so that's why. So when you see a positive there, positive 2, you've got to think, what x value do I have to put in to get 0? And it's the opposite of positive 2, which is negative 2, okay? So this is factored form, and it tells you the x-intercepts of your function, which is very useful. Now, let's have a look. I'm just going to see if I can zoom this page a bit. Oh, I can. That's nice. I'll zoom out again. All right. Now, let's have a look. There's a little file here you can click on to have a play with that. All right. So click on that file. It should open in your browser. There we go. Opening. And this is a cubic in factored form. So here we go. Now, K is 1, A is 3, B is 1, C is 2. No, B is negative 1 in this case, isn't it? Have a look. B is negative 1. If I put negative 1 there, I get a positive, don't I? Okay, if I play around with, let's start with A. A. Now watch what happens. Okay, now let's try and do it so it is a whole number. That's why it's easier to see. I've slid that up to 4 there. You can see there's a 4 there. And if I put x equals 4, I get 0, don't I? Let's try B. Now, if I take B to negative 2, B to negative 2, slide it, what does the equation become? It becomes x plus 2, because if I put x equals negative 2 into this equation, I get 0. Okay, now what about C? I'll take C up to 3. I'll take it up to 3, and I should get an x-intercept of 3. There it is. So there's an x-intercept of 3 there. Okay. Now you can also, I can change the k value, by the way. The k value will not change the intercepts. Have a look. No matter what I do, those intercepts will always remain where they are, because the k value doesn't affect the intercepts. Okay. It's only the A, B, and C value. Now, what if I put B to be positive 2? Let's see what happens there. If I put B to be positive 2, so sliding along, positive 2. Okay, B to be positive 2. There it is. What's the equation become? Look, x minus 2. So there we go. So why is there an intercept at x equals 2 when you've got x minus 2 as a factor? Is because when I put x equals 2 into that bracket, I get 2 minus 2, which is 0. All right, have a play with that, and then we'll come back to our PDF. Here we go. All right, let's move on. Or should I give you a question? Okay, here's a question for you. All right, see if you can work this one out. All right, so if what is a possible equation of a cubic with x-intercepts of, let's do 3, -4, and 5. Okay, a possible equation. So this is my question. I thought this is question 1. All right, so let's think about that. Pause the video, see if you can figure out the answer. All right, now let's change colors. All right, so what's a possible equation? Well, I know that if I've got the 3 intercepts, I know that it's in factored form. X minus A, X minus B, X minus C. Okay, now A, B, and C are the intercepts. So let's take the first one. Right, I'm going to put a comma here. I'm going to say let A be 3 and B will be -4 and let C be 5. Okay, so if you put those into the equation, what do you get? Well, we don't know what K is, so we'll just leave it as K. Now, A is 3, so it's just X minus 3. B is -4. Now, if I put B there as -4, it combines with that minus sign to get a positive, so I get +4 there. Okay, and then last of all, X minus 5. Okay, so that's how you do that question. Alrighty, now let's have a look at some special cubics. Here they are. Now this is a special cubic. I'll call this the basic cubic because it's probably the easiest one to draw. Now, special cubics are of the form kx cubed. They don't have any other terms, okay? Cubics of this form have an x and y intercept at the origin. There it is. You can see it passes through the origin, passes through the origin. If k is positive, it starts in the third quadrant and finishes in the first quadrant. And have a look, just like before, it goes from concave down to concave up, just like the other ones. Okay, the point of inflection is at 0, 0. All right. Now, if k is less than 0, just like before, it goes from concave up to concave down. All right. Now, what I'd like you to do is just indicate on your, oops, let's get rid of that. I want you to indicate where the point of inflection is. It's right at the origin. Okay. So, all right. So you can put a little arrow there and write down point of inflection. Now, you could also write POI, point of inflection. Point of inflection. All right, and because I do like coloring in, I'm going to click on my marker tool. I'm going to highlight concave down, and then it's changed the color. Let's go to green. And then this is concave up, okay? There we go. So the point of inflection is where it changes concavity. And let's do this one. Over here, concave up is here, concave up. Yep. And then concave down. Okay. And going back to the pen. So I want you to put a little dot at the origin there. that is a point of inflection. Now, just for abbreviation, I'm going to write POI. POI. The point of inflection is at 0, 0. I might just add that in here as well. Point of inflection at 0, 0. Okay. Now, the other thing to highlight about this is that at the point of inflection, the curve is actually horizontal. So if you look at it, it flattens out and it becomes perfectly horizontal at the origin, and then it starts curving again. Same thing here. So concave up, and then at the origin, the curve becomes perfectly horizontal and then concave down. Now, how does the coefficient k change the shape of the graph? We'll have a look. Now, here's 5x cubed, here's x cubed, and here's 0.25x cubed. So you can see that as the coefficient gets closer to 0 in terms of its value, so as the value of the coefficient of x cubed gets closer to 0, so 5 to 1 to 0.25, you can see the curve is getting wider. The other way you can think of it is as the values of the coefficient of x cubed move further from 0, the curve gets steeper. Okay, so there's a little link here, you can see that. Okay, so I'll click on that link and let's have a look. All right, so have a look. K is 1 at the moment. What happens when I change K to a different value? Okay, so as K gets further from 0, yep, the graph gets steeper, and as it gets closer to 0, let's see how close I can get. I should be able to get to 0.1. Whoops. There we go. Quite flat. Now, by the way, K is not allowed to be 0 because the cubic ceases to exist. So K not equal to 0, but K can be anything else besides 0. Now, as K moves further from 0 in its value, the graph gets steeper. And as K gets closer to 0 in its value, the graph gets flatter. Okay? All right. Now, let's go back to your notes. So here, where I said as the value of K increases, technically I should have said as the value of K moves further from 0, the graph gets steeper, and over here it says as the value of K decreases, so I should have put down there as the value of K gets closer to 0. So let's just fix it up, and maybe I'll fix it up in your notes as well. So as the value of K, right, moves away from 0 or further from 0, and over here it should be as K gets closer to 0, as the value of K gets closer to 0. Okay, all right, now moving right along. Now what happens when we add a constant to the basic cubic? So if I've got kx cubed, what happens to when I go plus d? Well, that just moves the basic cubic, so that means this cubic, this one here, that just gets moved up or down by d units. So here's an example. So here's my basic cubic, y equals 2x cubed, or a basic cubic. Now, 2x cubed plus 1 is just this graph here. Let me see if I can trace it and then move it with the cursor. I don't know if I can. I'll try. So, whoops. Now, I'm tracing. Okay, can I grab that with a cursor? It doesn't look like I can. Now, here we go. I'll try. Can I grab that? Oh, yeah, I can. Okay. So it just moves up by 1 unit. Okay. Oops. Approximately, anyway. All right. You can see that there. So this graph here has just been moved up by 1 unit. And what about 2x cubed minus 2? Well, that's just this graph here, the first one, moved down by 2 units. Okay. Now there's a little GeoGebra app here, web page. Just click on that and you can see how that works. So have a look. Here's my basic cubic. Now if I change the K value, no, I just realized that is not the right file I had to show you. I'll fix that link up for you. I'll do it here. I'll go to GeoGebra. Where's GeoGebra? Here we go. All right, let's now know that mistake. I can fix it. So I'll just open GeoGebra here. Okay, so if I type in y equals k times x cubed plus d, okay, enter, create sliders. Okay, here we go. So here's my equation. Now if I take, I'll put that as 2 there. Yep, and I'll take this back to 0. Okay. What else I'll do is I'll just make sure that the increments on this slider are 1 unit. That way it'll be easy to see. Okay. All right. So here we go. So if I change it, so look at the equation, 2x cubed plus 1. So what happened to my basic cubic? Moved up 1 unit, then up 2 units. Okay, look at the equation. So the plus 2 means the basic cubic, 2x cubed, has been moved up 2 units. We go to 3, it's been moved up 3 units. Okay, let's go back to the beginning. Here's my basic cubic. What if I change d to -1? Okay, so that is the basic cubic moved down 1 unit, and I can move it down 2 units. What happens to the equation? I get a -2 at the end there. So that d value, so if you're looking at y equals kx cubed plus d. Okay, now here's the equation we're looking at. That plus d just moves the kx cubed up, doesn't it? Because if I type in another function f of x equals k times x cubed, let's do that, it's the basic one. No, that's not right, I think I'll put too many brackets there. F of x equals k times x cubed. Okay. There, the basic one is. Oh no, that didn't work. Hang on, let's undo that. All right, let's type in g of x. I can put in a different function. G of x equals k times x cubed. Okay, so there's my basic function that I start with, and all that happens is, if I take this back to 0, it's that basic function just gets moved up, right, or down. Okay, so I'll fix up that file for you, and then you can have a play with that. All right, so let's close that down. I'll minimize it. Okay, moving right along. Now, here's some examples for you to do. So you can pause the video and try these questions. Here are 4 different cubic equations. 1, 2, I tell a last 5. And you've got to match those to these graphs. All right, so pause the video and have a go, and then you can check your solutions with me. All righty. Okay, and we're back. All right, so how would you do this question? All right. Okay, so let's have a look. Well, first of all, I would be looking at this here. And I'll be thinking, well, that's got a positive coefficient of x cubed. So I know that goes from concave down to concave up. Okay. The second thing I'm looking, so I know that it goes from concave down to a concave up like that. Okay. And also I'm looking at the constant term. That's the y-intercept. So I'm looking for something which goes from concave down to concave up, and it's got a y-intercept of 40. So it's got to be this one. Y-intercept of 40 and concave down to concave up. Okay. Now, what about this one? Well, that's got a negative coefficient of x cubed. So I know that it goes from concave up to concave down. And if I look at the constant term, that's the y-intercept. So I'm looking for a y-intercept of negative 40 and a function, a cubic, which goes from concave up to concave down. So there's negative 40. And just checking, it goes from concave up to concave down. So that's that one. So I'll be saying that this here is B. Sorry, that's not right. This one is A, and this one is B. Okay. It might help if you write the equation down. So this one here is y equals minus x cubed, or you can draw arrows if you want, x cubed plus x squared plus 22x minus 40. And this one here is y equals x cubed minus x squared minus 22x plus 40. Okay. All right. Now what about the other ones down the bottom? Okay. Now, these are all equations of the form y equals kx cubed. Yes. And, right. Now, I notice that these all go from concave down to concave up, every single one of them. So I know that the k value is positive, right? And I notice that they get wider as well. Notice they get wider. Now remember we looked at it and we said that the bigger the k value, the steeper the graph, and the closer to the value of 0 that k is, the wider the graph. So I'm going to pick from here, I've got 3 graphs here. The steepest one will be 5x cubed. Okay, so I'm going to come down here. Let's have a look. Just checking that my notes match. Yep. Okay. So that means the steepest one will be y equals 5x cubed. So that's this one here. So this here is y equals 5x cubed because the k value is the biggest. The flattest one, that's not very good, is it? I have to fix that. Okay, so the flattest, so that's cube there. Okay, the flattest one will have the value of k closest to 0. So that's this one here. So y equals 0.25x cubed. And that means this one must be y equals x cubed. Yep. Okay, so this one here must be y equals x cubed. All right, there we go. All right, now, what are some important ideas here? So, here are some important ideas. If the coefficient of x cubed is positive, we know it goes from concave down to concave up. All right, that means it begins in the third quadrant and finishes in the first quadrant. Okay, concave down, concave up. Okay, so here's an example down below. Right, you can see that the value of the coefficient of x cubed is positive. So it goes from concave down to concave up. So if I was to figure out how to sketch that, I know that it starts in the third quadrant and finishes, so it starts, maybe it goes like this, something like that. Starts in the third, finishes in the first. Okay. Now, is that an accurate sketch? No, because just realised that that's got a y-intercept of 10, so this should be higher. So maybe I can just grab this here and move it up a little bit. Okay, that'll do. And let's just get rid of this arrow here. There we go. So let's call this here the y-intercept should be 10. Okay, and there we go. All right, and what's the other key idea? If the coefficient of x squared is negative, then the graph will go from concave up to concave down. That means you're in the second and fourth quadrant, starting in the second, finishing in the fourth. So here's an example. Notice that the coefficient of x cubed is negative. Now the y-intercept is -5. So because that's negative there, the coefficient, that means I'm starting in the second quadrant and finishing in the fourth quadrant. So if I was going to sketch this, and I've got to go through -5 on the y-axis, so maybe it goes something like this. Oh, there we go, there's the arrow there. That worked out. And I'll call this -5. Okay, so these are the important ideas here. If k is negative, if the coefficient of x cubed is negative, you start in the second and finish in the fourth quadrant. All right. Okay. Now, translations. Okay. So we're going to look at something of the form kx minus b cubed and kx plus b cubed for f of x. Now, the cubic function kx minus b cubed is just the basic cubic, kx cubed, here it is, here's your basic cubic, moved right by b units. So have a look. Here is, let me just zoom in a little bit. Okay, so here's 2x cubed, and here's 2x minus 3 cubed. Now look what's happened. Your point of inflection has moved to 3. So the whole function has moved 3 units right. So this particular function here, so if I was to describe this function, the second function, I'd say, well, this is just y equals 2x cubed moved 3 units right. Okay. Now let's look at something else. We'll come down a little bit. So if you get a cubic function x plus b cubed with k out the front, that's just your basic cubic, kx cubed moved left by b units. Okay, left. So let's have a look. Here's your basic cubic function, or a basic cubic function, and here's 3 brackets x plus 2 cubed. So that's this function here, original one, has just been moved left 2 units. Okay, so what I could write about this second function is that this is just y equals 3x cubed, right, moved left by 2 units. Okay, left by 2 units. You can also think of this as y equals 3 outside of x minus negative. 2 negative make up a -2 cubed. So you can think of it like that. So there's your -2. It's moved left 2 units. Okay, now I'll zoom back down again. You can click on this app here. This should work. And you'll see how this works. Okay, so here's your basic cubic function, right? So what's happening? So there we go. So I'm going to move the function right. Look what's happening to the equation. Okay, so I'm moving compared to the green function, the blue function is the green function moved right by 6 units now. Now if I take it back to the origin, now look at the equation. X plus 1 cubed is just the basic cubic moved left by 1 unit, and then x plus 2 cubed is the basic cubic moved left by 2 units, and so on. Okay, so you can have a play with that, and we'll go back to this one. All right. So another another different translation here. What if you've got kx minus b cubed plus c? So what happens when we add a plus c to the end of the equation? How does that change it? Well, that just moves the graph up and down. So here's, let me just zoom in a little bit. Okay, so you can see here is the cubic 2x minus 3 cubed. And look at this, I've got a little plus 1 on the end. What does that do? That just moves the whole graph up by 1 unit. So I've just basically moved everything up 1 unit. All points on that function have been moved up by 1 unit. Okay, so the plus c just moves it up or down. Let's have a look at another example. What about 2x minus 3 cubed minus 2? Well, that's just this function here moved down by 2 units. Okay, so the original function, let's see if I can draw this. Ooh, nearly. Okay, so that pink function, if you like, was the original function, and that's just been moved down by 2 units because of that negative 2 there. Okay, so the term on the end tells you up or down. So if the term on the end is positive, so if that term on the end is positive, it's going to go up, and if it's negative, it's going to go down. Okay. All right, so there is a little applet here you can play with to have a look at that idea. So we'll have a look at that. Okay, so the k value is 1, the b value is 3, but we want to see what happens to the c value. You can see that graph is moving up, and then, okay, so there's my original function. What happens when I add a constant to the end, which is negative? It goes down. Okay, all right, down. So compared to the original function, what's happening? So there's my original function just there, and putting a negative 1 on the end moves it down 1 unit. Putting a negative 2 on the end moves it down 2 units, and so on. Okay. All right, so you can have a play with that. Obviously, this moves it sideways, and then this moves it up and down. Okay, and that will change the steepness of your cubic. All right, moving right along. Now, over to you. You're going to sketch 10 cubics. I've given you some space to do that. Here are some sketching hints. Determine the x and y intercepts. Determine the coefficient of x cubed, because that will tell you the quadrant you're in. If the coefficient is positive, then you're going to start drawing up first, starting from left to right. If the coefficient is negative, then you start drawing down first. Let's have a look at the first one. Okay. Now, let's just change colors to blue. All right. Yep. All right. So for this one, the first thing I'll do is look at the coefficient. Okay. So coefficient is positive, right? That means if I did a little number plane over here, that you'll be starting in the third quadrant and finishing in the first quadrant. Okay. The other thing to look at is intercepts. Now, this is your basic cubic. Remember, your basic cubic is kx cubed. And if you work out the intercepts, when x equals 0, y equals 0. Okay. You also know for your basic cubic, which is a positive coefficient there, it's going to look like this. It should be horizontal through the origin, looking like that. So realistically, you only need the 1 point, but if you want to plot a couple of extra points, you can do a table of values. Okay. So doing my best with this digital pen, it's a bit tricky. Now, table of values, you could just do -1, 0, and 1. If I put -1 in there, I'll get -1 cubed is -1, times 2 is -2. Put 0, I'll get 0, and then 2. Okay, now, my scale I'm going to use is I'm going to put 1 there and -1 so I can just makes it easier for me to draw my graph there. because it's not so steep. And here is 2 and negative 2 on the y-axis. So label your axes y and x. And I've got a point just there. That's my point of inflection. And I've got 1, 2 here, and negative 1, negative 2 here. Okay, so now I know that I'm starting in the third and finishing in the first. So I'm going to come up through here. Now I've got to flatten out here. Make sure you flatten out. Should be perfectly horizontal there, and then through the other point. Okay. Easier with a normal pen than a digital pen, but that's first attempt. Coming over here. Now, again, I'm looking at the coefficient of x cubed. The coefficient is -1, right? I could write this as y equals -1x cubed. Now, because it is negative for the coefficient of x cubed, I know that I'm starting in the second quadrant, finishing in the fourth quadrant, okay? Now, looking at intercepts, well, because it's the basic cubic, I know that x equals 0, y equals 0. And I know the point of inflection is also x equals 0, y equals 0. So here it is. So now, just as a sketch, you could just draw it now if you wanted to. Horizontal there. Whoops, just realized I'm doing that wrong. Okay, because don't forget I'm starting in the second quadrant and finishing in the fourth. So I meant to start here, of course. So flattening out should be perfectly flat. Very hard with the digital pen, but getting there. There we go. Good enough. Okay, and again, if you wanted to do a table of values to plot some extra points, if you want some extra points, I would just do, for these ones, basic ones, -1, 0, and 1. Okay, so it's going to be -1 cubed is -1, and with the negative sign out the front, you can have positive. That's 0, and that'll be -1 there. So if you're looking at plotting points, okay, obviously there's your point of inflection. And if I was going to put a, well, I haven't drawn it to scale, but basically 1, -1 would be 1 point. So maybe it's down here, so I missed that bit. So if I make that 1 there and -1 there, and then -1, 1, that would be up here somewhere. Okay, 1. So maybe I should have drawn it like this instead. Through those points, flatter, and then through that point like that. Anyway, let's look at the next one. Okay, now, straight away, if I'm looking at x cubed here, I notice that the coefficient is positive. All right, positive, that means that I'm starting in the third quadrant and finishing the first. I notice also that I can find the intercepts. Okay, so if I sub in x equals 0, what do I get? I get y equals 2. Okay, so that's the y-intercept. Now what about the x-intercept? Okay, I sub in 0 for the y, and I get x cubed plus 2. And that gives me -2x equals x cubed. And then you're going to cube root both sides to get rid of the cubic term for the x. So it's going to give you x equals the cube root of -2, which as a decimal is -1.3 approximately. Okay. All right. Now, more importantly though, I'm thinking of this as y equals kx cubed plus c. And I know that plus c on the end will move it up and down. So because that's a +2 here, that +2 is going to move your basic curve x cubed up 2 units. All right? That means your point of inflection will also be up 2 units. So let's have a look. I know it goes through, there's my y-intercept at 2. All right. So if my basic x cubed graph is like this, what is x cubed? So if this is y equals x cubed, what does x cubed plus 2 look like? Well, that's just going to be the same sort of function, but you're going to be going through negative 2 for the point of inflection. It's just going to be moved up by 2 units. Okay. Now, of course, if you wanted to do this more accurately, you could do a little table of values here. Okay. You could go x and y, and I would just do some basic points again, -1, 0, and 1. If you put -1 in there, I'll get -1 plus 2 is 1. That'll be 2, and that'll be 3. So if I was going to do this a bit more accurately, I could rub this out. Here we go. Get rid of this. And okay, so I would be looking at using this scale, -1 and -1 and 1, and then here is 2, there is 4, so I'll go by 2s. So 0, 2, right, there's one of my points, and then -1, 1, there's another point, and then 1, 3, there we go. So sketching that, I would be going something like this, going up, up, up through that point, horizontal at the point of inflection, and then through there like that. Okay. All right. Next question. So we're up to 4. We've got 6 to go. This is a big, big document. All right. Now, again, x cubed. All right. So x cubed, that means I could write this as y equals 1x cubed minus 8. So straight away, I know that if I'm looking at a number plane, coefficient of x cubed is positive, so I'm starting in the third, finishing in the first. All right. I can also find some intercepts. So to get the y-intercept, okay, I'm going to sub in x equals 0. Okay, if I do that, I get -8. Yep. For the x-intercept, I could also do that. Sub in, put in y equals 0. What does that give me? That gives me 0 equals x cubed minus 8, and then x cubed equals 8. Cube root both sides, cube root, and cube root. Make sure you put the 3 in there. And that's going to give you x equals 2. Okay. You could also do a little table of values, but let's think about what this really is. We know what the basic cubic function looks like. It's like this. That's y equals x cubed. Okay, so that's y equals x cubed. So what is this -8 doing? It's moving this basic function down 8 units. Okay, so if I come over here, 2, 4, 6, I'm going to put a scale of 2's here. So -2, -4, -6, and -8. All right. Now, I know that I'm going through -8. I know that my point of inflection, by the way, here's my point of inflection. Point of inflection is going to move down 8 units as well. So as a sketch, I know that I'm coming through here, and I'm going horizontal at -8, and then I'm coming up here. Okay. Now, I know that for my x-intercept, it's 2. So maybe I should have, before I did that, because 2 is pretty easy to show on the scale, what I should have done there is just said, look, here is 2. I know I'm going to go through 2 there. So maybe I'm coming up through here, then horizontal at the point of inflection at -8, and then coming up through, whoops, there we go, good enough, There shouldn't be a little kink there. It should just go straight up. So there's your function. Okay. And yes, you could do a table of values if you wanted to, but I think the only points you really need to show there will be the x-intercept and the point of inflection. Okay, now what about this one here? Well, first thing I'm going to look at is the coefficient of the cubic term. Now, if I expanded this, the cubic term would be minus 2x cubed. Okay, now that is negative, the coefficient, so I know that I'm starting in the second and finishing in the fourth. Okay, arrow there, arrow there. Okay, what else could I do? I could find the y-intercept. Okay, for the y-intercept, x equals 0. Okay, so what happens there? I get minus 2 and then 3 cubed, which is minus 54. Okay, now what about the x-intercept? So for the x-intercept, I'm going to put y equals 0, and then that gives you 0 equals negative 2 outside of x plus 3 cubed. Now, I could just look at this by inspection and say, look, what value of x am I going to put in to get 0? If you solve that, you should be able to see that you can get x equals negative 3 just by looking at the equation. So to continue the solution process. If you did continue the solution process, you would divide both sides by negative 2. Right, that would give you 0 on the left-hand side and x plus 3 cubed on the right-hand side. Cube root both sides and then subtract 3, and you'll still get negative 3. Okay, now, more importantly, what is this going to look like? I'm going to compare it to the basic cubic. Now, the basic cubic that I'm looking at here is, because it's negative, here's my basic cubic. All right. Now, what does that plus 3 do to my basic cubic? So this basic cubic I've drawn as y equals minus 2x cubed. So that plus 3 is going to shift your basic cubic left 3 units. Okay, so I'm just going to come over here, put in negative 3. That's where negative 3 is. And I know that I'm starting in the second and finishing the fourth. So I'm just going to draw that through. Now I've got to get flat, really flat here. I think I missed it, but anyway. And then I'm going to come down. Here should be perfectly flat. Close enough. Okay, now don't worry about a scale for the y-axis here. Because I only cross at one point, I actually don't need to show the scale. So that negative 54, I'm just going to show it here. So, well, here's my scale. This is negative 54 just here. Okay, so let me just rub out this bit here. There we go. And then pen, and I'll finish that arrow there properly. There we go. All right, so there's your function. All right, now, what about this one here? We're going to follow the same process. All right, let's change colors. Pink. Actually, I like orange better. Here we go, orange. Okay, so if I expanded this, the cubic term would be minus 2x cubed. Now look at the coefficient of x cubed, it's negative 2. Negative 2, so that means I'm going from concave up to concave down. So I'm beginning in the second and finishing in the fourth. Okay, so that's how I know where I'm going. All right, little arrows there to show it. Now, I'm also going to compare this graph to the basic cubic, or the equivalent basic cubic. There we go, there it is. So I'm going to say, look, the basic cubic is negative 2x cubed. So what does this negative 4 do? That's going to move it right 4 units. So I'm going to move this function here 4 units right. So 1, 2, 3, 4. There it is. So 2 there. And I know that my point of inflection is there. I could probably also find the y-intercept. So if I want to find the y-intercept, it's going to be pretty big. Sub in x equals 0. You're going to get y equals 2. Whoops, I just realised I made a mistake. What was my mistake? I misread the question. Okay. There is no minus, is there? Okay. So that's all right. I'll fix that up. If there's no minus, that means it's beginning here and beginning here. Sorry about that. There we go. So that means, and no minus there. I would have to rub that up too. Hang on. All right. So it should just be 2x cubed. All right. So that means my basic cubic is this. All right. There we go. It's like that. There we go. That's better. Okay. Read the question. I thought there was a minus there. Now, if I put in that, I get negative 4 cubed. That's going to give you, now negative 4 cubed is negative 64. So it's going to give you negative 128. That's pretty big. I'm not going to worry about that yet. This is what I'm going to do instead. I'm going to just sketch my cubic. There it is. Now, you might be saying, hang on, didn't you say it starts in the third quadrant? Well, it does. If I extend this, keep going down here, there we go. It does start in the third quadrant. And if I extended this down here, then I would say there's minus 128 for the y-intercept. Okay, so it does start in the third quadrant and finish in the first. Okay. All right. Now, what if you didn't realise that it's going through 4? You can still work it out, because if I find the x-intercept, I'm going to sub in y equals 0. That's going to give you 0 equals 2 outside of x minus 4 cubed. And the only x value that you're going to be able to sub in there to get 0 is x equals 4. So just by inspection, you can see x equals 4 from that. Oh, 4 to go. All right, so let me just rub out this bit here and this bit here. Okay. All right, so next question. All right, moving right along. And let's change colors to pink. All right, now I'm going to look at the cubic term again. If I expand this, I'm going to get x cubed times negative 2. So the cubic term is negative 2x cubed. Yep. Now, this is negative. Got that one right this time. That means I'm starting in the second and the fourth, finishing in the fourth quadrants, okay? Now, I'm also going to think of this in terms of the basic cubic. All right, now here's my basic cubic that I'm going to draw, this one. That basic cubic is y equals negative 2x cubed. Now, I've got two translations happening here. That minus 3 there is going to move this basic cubic right 3 units. And this plus 2 here is going to move it up 2 units. So I'm going to move right 3 and then up 2. Okay, so I'm going to go right 3 units and up 2 units. Okay, that's what's happening. What else can we do? So that means my inflection point, so my point of inflection, without doing much working out at all, my point of inflection, if it starts at 0, 0 and it goes right 3 and up 2, my point of inflection will be at 3, 2. That's for starters. Now what about my y-intercept? Can I work that out? Y-intercept sub in x equals 0. Now that will be, here we go. So I'm going to get y equals negative 2. And I put 0 in there, you're going to get negative 3 there. Cube it plus 2. So that's going to give you, now negative 3 cubed is negative 27 times negative 2 is 54. That's going to give you 56 there. Okay. That should be correct. Yep. And could I find my x-intercepts? Yes, you could. So just over here, see if I've got room to do this. Change colours to make it clearer. All right, so you're going to have, now for the x-intercepts, put y equals 0. I think I'm going to run out of room here. So that's going to be 0 equals negative 2 outside of x minus 3 squared plus 2. Okay, take 2 from both sides, you're going to get negative 2 equals negative 2 outside of x minus 3 squared. I think I have to keep working down the page here. And then we're going to divide through by negative 2. Okay. That cancels that with that, and that gives me 1 equals x minus 3 squared. Okay. Now, what am I going to do after that? I'm going to square root both sides. So I'm going to get 1 is equal to x minus 3. Yep. And then I'm going to get x equals 4. Okay. Now, I could have square rooted both sides there, but that would give me a false point. That's interesting, isn't it? So let's have a look. So let's not overcomplicate this. I'm just going to plot my point of inflection first. So 1, 2, 3, 2. So there's 3, and here's 2. So my point of inflection is going to be there. Okay. Now, y-intercept is pretty high. That's true. So it's going to be hard to show on this. So it's not going to be exactly to scale, but that's okay. Now, I'm not going to go through 4 on the... So here's my x-intercept here. So I'm basically coming through here flat and then down. Okay. And using the current scale I've got, I'm not going to be able to show 56 there. I can't show 2 and 56 on the same axis there, unfortunately. Okay. Now, normally when you square root, you would take plus or minus the square root. That's not going to work in this case. Okay. Because then you're going to get negative 1 and negative 4, which is not a point. So, yes. Okay. All right, so let's move on then. There's my function, and I guess technically I should extend that up. Keeps going up there. Okay, it keeps going down there. All right, so let's look at the next one. I'm going to rub that out. Now, just realised, where was my mistake? Where was my mistake? Here. Now, square root. That should be a cubic, shouldn't it? Okay, so I'll fix that up. All right, got carried away. That's a 3. Okay, let me just rub this thing out again. Okay, fix that whole thing up. Okay. All right. That was a silly mistake. All right, here we go. All right, so let's do this in red. All right. Now, that should be to the power of 3. That's better. And then I should have on the end plus 2. That's better. Okay, so that's going to give me minus 2 equals minus 2 x minus 3 cubed. Okay, divide by minus 2. Okay, divide by minus 2. You're going to get 1 equals x minus 3 cubed. And then I'm going to cube root both sides. Cube root. And then cube root. Put a little 3 there. That's going to give you 1 equals x minus 3. And that gives us 1 x-intercept of x equals 4. Okay, that works out. So my apologies there. I wrote a 2 there instead of a 3, but I'll fix it up now. So let's look at the third last graph now. Okay, so I'm just going to rub that out. Create room for the next question. Okay, now this is going to be easier to sketch. It is a cubic in factored form. Okay, a cubic in factored form. Okay, so the good thing is this is in factored form. So straight away I know that the x-intercepts will be x equals negative 4, x equals 3. These are the x values, which when I put them into the equation, gives me 0. So let's put 2 here, 4 here, and negative 2 here, negative 4 here. Now the other thing I can work out is the y-intercept. Now if I sub in x equals 0, what do I get? I get y equals 2 outside of 4, outside of negative 3, outside of negative 1. So what's that? 3, 4 is 12, that's going to be 24. That's good. Now the other thing I should be looking at is the cubic term. So if I look at the cubic term, well, it's going to have a 2 in it, and x times x times x is x cubed, so 2x cubed. So straight away I know, because I've got a positive coefficient of x cubed, I'm beginning in the third quadrant and finishing in the first. Okay? All right, so let's plot our intercepts. Here we go, in negative 4, right? 3, and 1. 1 is there. Okay, I'm starting here in the third, finishing in the first, and don't forget I've got a positive y-intercept, so I'm going to have to be careful there. So I'm going to go through here. Whoops. Now I've got to turn back down. Yep, go through there, and then finish in the first quadrant. There we go. All right, so now I cross the y-axis where? Somewhere. Let's just call it 24. It's just going to be some positive number. You don't need a proper scale here. You just need to show one y value in this case. All right, so that's that one done. That's easier. Let's try number 9. Now, straight away, I'm looking at its factored form. So I know that there's intercepts at x equals 5, x equals negative 2, because these are the x values which give me 0 for the function. Okay, as the x-intercepts. Now, what about the y-intercept? Sub in x equals 0. So what do I get? Y equals negative 2 outside of negative 5. Yep, outside of 2, outside of negative 1. Okay, so what's that going to give me? I've got negative 5 times negative 1 is 5, times 2 is 10, that's negative 20. Okay. And what's else something that I consider? Well, look at the cubic term. The cubic term will have negative 2, and x times x times x is x cubed. Here's my cubic term. So I notice the coefficient is negative. So that means I'm starting in the second, finishing in the fourth. Okay, so let's put some numbers on here. 2, 4, 6, then negative 2, negative 4, negative 6. Okay, I know where I'm starting, here, finishing here. Now, let's have a look. And I've got a negative y-intercept of negative 20. Okay, so I have to cross the y-axis somewhere at negative. So let's plot our intercept. So 5, there's negative 2, and then 1. Okay, and I know where I'm starting. Here it is. So starting here, whoops, yep, and I've got to come back up through here and then come back up or down. Oops, there we go. Bit bodgy with the digital pen. That's not very good. I'm going to delete that and try for a better result. Okay, let's try again. All right, so coming through, then up, around, and down. That's smoother. It's better. Okay, so I'm just going to call where it crosses at negative 20. There we go. So crosses there at negative 20. Okay. Now, last one, number 10. We made it. All right, factored form again. All right, now, so the y-intercepts will be at x equals 3 and x equals negative 1. So the x-intercepts are there. For the y-intercept, I'm going to sub in x equals 0. So what do I get for that? I get y equals, brackets, minus 3, brackets, 1 squared. Okay, so that means I've got a y-intercept of negative 3. Looking at the leading term, so x plus 1 squared, it's going to give me an x squared term times x is x cubed. So my cubic term is x cubed, so think of it as 1x cubed. The coefficient is positive, so straight away I know I'm starting in the third, finishing in the first. Okay, now the other thing to consider is this has a double root. Okay, I could write this as x minus 3, x plus 1, x plus 1. Okay, now before we sketch, I want you to think back to when we did parabolas. If I gave you a parabola like this, x plus 1 squared, then at negative 1, the x-intercept, the turning point is exactly at x equals 1. That's a very bad parabola there. Let's try it again. All right, now try that again. So, okay, there we go. All right, so that there is your parabola. So that means over here at the double root, x plus 1 squared, at x equals negative 1, you're going to have this sort of situation here. You're going to have like a parabola part of the curve. So first of all, where am I starting, where I'm finishing? Starting here, finishing there. Let's put some numbers on here. 2, 4, minus 2, minus 4. Okay, and I need to get to negative 3. Negative 3 is here somewhere. Yep, negative 3 on the y-axis. All right, so let's sketch that. All right, so we're starting here. Actually, let's put the y-intercepts, x-intercepts in. So negative 1. So x equals negative 1. You're going to have your double root there. And x equals 3, just a single root there. Okay, so watch this. So I'm starting here. And now I've got a turning point here. I've got to have my turning point just there. Whoops, came in too steep. Let's try that again. Okay, all right, so okay, and then down, then up. There we go. That's it. Good enough. Okay, so here it should have touched. Missed it there. You're just touching, so your turning point there is actually sitting right at negative 1, and it passes through 3 on the x-axis and it passes through negative 3 on the y-axis. So that's that function there. Okay, now I think that is it for the curves. So what I'd like you to do then is, once you've copied all that down, big lesson today, probably the biggest one for the year. Questions I want you to do are 312, questions 1 to 10 every second problem. So you know what that means. 1, A, C, E. 2, I don't know what is going on there. Hang on. What is happening with these letters? All right, let's try that again. Okay, so I want you to do questions 1 to 10. Oh my God. I don't know what's happening there. The program is malfunctioning. Can I type this in? I think I can. Right. Okay, so text box. Auto snap, no. Where is the text box function? Can I insert that? I'll just tell you. I just want you to do 312 question 1 to 10 ESP. I don't know what's going on with that text. Okay. Tool. I don't think I've got a text box in here that maybe text. Can I type here? Yes. Okay, so let's try this. 3.12, 1 to 10, ESP, every second problem. Okay. Thank you for listening.